Well, we thought the congressman was in the elevator. We got word the congressman was in the elevator. We're not sure what elevator, what building. So, since he's unaccounted for, we're going to go ahead and bring the next panel up here. And I would ask them, when the congressman gets here, just pause, stay up here in your seats, it's fine. And then we'll let the congressman speak, and then we will pick up just like we did. Appreciate your flexibility. Hopefully it's not right in the middle of the high point, the climax of somebody's remarks, but I'm sure it will be. Nice luck. So, it was very interesting when I went out to and visited the Bodega Marine Laboratory. Those of you who've never been there, it's in a beautiful place in coastal California. And I had a chance to visit with the folks there and also with Dr. Rick Grosberg, who's the head of the Coastal Marine Science Institute at UC Davis, which is where the Bodega Marine Laboratory falls under. And I was really amazed by long-standing program of great agriculture, great aquaculture research, including some amazing work that's been done with white abalone and regrowing the population of what otherwise would likely be an extinct species. Many other things look at the impact of ocean acidification on several types of shellfish and things like that. So it was I was really intrigued. And then we sat down and started talking a bit and learned about the amazing agricultural program at UC Davis. And I think, as I talked about in my question to Congressman Bonamici, of bringing agriculture and oceans together for food security in the future. So then we're here. So that's how I met Dr. Rick Grosberg. So he's got a lot of great ideas, and it's sort of interesting to me that the moderator of our first panel was from Harbor Branch over on the East Coast, and now we've gone from the Treasure Coast to wine country. So with that, I will turn it over to Dr. Rick Grosberg from UC Davis. Thank you very much, Rick. It's great to have you here.
Thanks.
All right, man.
Thanks, John. Well, thank you all for being here. I've been totally overwhelmed this morning by assimilating the fact that the topic that we have for this afternoon's panel on food security really encompasses just about everything we've talked about so far, including food safety, law, regulation, policy. In fact, I think that the whole concept of food security and the role of the oceans in providing global food security is a question that crosses just about every disciplinary boundary, geographic boundary, climatological boundary, political boundary, ecological boundary, cultural boundary, and economic boundary that we can possibly imagine. And so what we've tried to do in this afternoon's session is to bring together, I'm trying to see where, let me go, there we go. Good, thank you. Is to bring together a group of colleagues who variously represent some of the ocean's major roles in food security. And we're going to be really investigating and examining during their presentations three perspectives. One is the ocean's role as a driver of terrestrial and atmospheric processes. That is, the ocean and the links, the physical and climatological links that inevitably bring land and sea together. And to speak to that question will be Caroline Clayson. She's a senior scientist at Woods Hole Oceanographic Institution. The other perspectives include the ocean's role as a source of food for our planet. And especially we have two experts, Michael Rubino, Director of Aquaculture at NOAA, and Sebastian Bell, the Executive Director of the Maine Aquaculture Association. And they'll be speaking to the role of aquaculture and mariculture in providing food from the sea. And there's, of course, another hugely important component of agriculture, if you will, from the sea, and that's not just aquaculture, but it's also wild fisheries. And so I'm relying on myself and a few members of the audience, or all of you, to make a contribution to speak toward the questions of the role of natural fisheries and wild fisheries in providing food security from the sea. And then finally, Kolo's here, excellent. Kolo Rathburn, who is a representative of the staff of the Senate Appropriations Committee on Commerce, Justice, and Science, And Kola will be speaking to the question of how do we develop a coherent policy that brings together all the diverse components of food security from the sea. So just to start my brief introductory remarks, I want to just remind us that we live on a very small and very blue and highly interconnected planet. And the question of food security really can't be thought about in totally local and totally national kinds of concepts, which makes the problem, I think, a huge and enormously important and challenging problem too. People move all over the world. There are ships that move all over the world. There are planes that move all over the world. And there are ocean currents. And as you can see in the central diagram, there are atmospheric currents that link every part of our planet into one entity. The land and the sea on this planet are not only linked by the movements of people, planes, trains, automobiles, and ships, by ocean currents and by atmospheric currents. They're also linked by the way we get food from the sea. And I'll talk a little bit about that in just a second. But one of the most obvious ones that we've just barely begun to talk about today is the fact that many of the ways that we grow food on land rely on food from the sea, namely fish, to supply the grain that feeds the pigs, that feeds the chickens, that feeds the cows. And so, in fact, when we were talking a little bit earlier about the Chinese and the role of the Chinese in buying out a quarter of the hog farming industry in the United States, there's also an important link to the sea in the pigs. So all of those links, I think, are really important links for us to think about. I'm director of a fairly newly established organization called the Coastal and Marine Sciences Institute at UC Davis. And this illustration shows Bodega Marine Laboratory, which is the primary research infrastructure of the Coastal and Marine Sciences Institute. And the Coastal and Marine Sciences Institute was designed to embody, I think, a new generation in how we think about the management of marine resources and the sustainability of marine resources. So rather than thinking about a completely self-contained College of Marine Sciences or Department of Marine Sciences, we recognized on the main campus in the Bodega Marine Laboratory that we have a very distributed and large community of over 150 researchers who consider themselves to be marine scientists, natural scientists, social scientists. There are people in the School of Veterinary Medicine, the College of Biological Sciences, the School of Letters and Sciences, the College of Engineering, and the School of Law, who all consider themselves to be marine scientists. And so we built a virtual institute that brings together Bodega Marine Laboratory and the resources that are available at Bodega Marine Laboratory with this much broader and very nimble community and very interdisciplinary community of collaborators at UC Davis to really address some of the dynamic and major challenges, especially in our coastal oceans. And now I'm going to take a break. Okay, well, back to the world as a small place and an interconnected place. I told you pretty much all I want to tell you about the Coastal Marine Sciences Institute, but really the key issue for us, and I think before all of us today, is how we can build partnerships and relationships and collaborations to address the issues the challenges of food security on the planet. And I just wanted to sort of give you a little bit of a perspective here of where my part of the world is. My part of the world is shown there in bright fluorescent red. And that bright fluorescent red shows you one of the most productive places, in fact, one of the four most productive places and diverse places in the coastal oceans of the planet. And the reason that it is so productive is because of a process called upwelling, which brings nutrient-rich, somewhat acidic, and low oxygen water to the surface and fuels the base of the food web that drives all of the productivity that we see in places like California. It drives our incredible runs of salmon, our Dungeness crabs when they're not toxified by domoic acid, our rich kelp forests, and our aquaculture industry shown in the right panel by one of our partners. It also drives coastal fog, and this is here to illustrate the fact that in fact terrestrial and marine processes are completely linked throughout the planet, and especially in a place like California. Because without that coastal fog, we wouldn't have cows that make awesome milk, that make awesome cheese, and then in turn we wouldn't have the vineyards that make the awesome wine that so many of us like to drink. Now, there's an upper and lower panel there, but they both illustrate the same marine driver of two different kinds of highly productive and diverse and hopefully sustainable ecosystems. But they also are there to illustrate some of the conflicts between land and water and between our goals of sustainability in both of those realms. So, for example, the cows that make the great milk that makes the awesome cheese also, during periods of runoff, produce large numbers of pathogens and nutrients that run into the places that sustain the oysters and make the water less than pristine for the oyster growers. So I think one of the big challenges we have to face is how do we bring all of these people to the table and reach solutions to those kinds of conflicts and opportunities. And then finally, I just wanted to close in the next 2 or 3 minutes by highlighting the importance of partnerships and relationships in addressing a lot of the questions about food sustainability on our planet. And I think Roberta and a number of us here who represent academic institutions would put front and center the development of collaborations and partnerships with stakeholders and communities in furthering our understanding of sustainable food from the sea. And so this illustration here shows our partnership with Hog Island Oyster Company. That's Tessa Hill in the upper left. We provide the instrumentation that allows them to document the influx of acidified and hypoxic water into their grow-out operations so they can, in real time, adjust their grow-out conditions and their harvesting conditions. And in turn, this is, as someone said, I believe, a tide-to-table operation for Hog Island. They grow the oysters. They have their own hatcheries, which they've distributed all over the West Coast, and now even Hawaii, as I'm beginning to understand. And they also have an awesome restaurant operation, as some of you may know, or you should try them. Or you can just go to Hank's Oyster Bar over on DuPont Circle and have Hog Island oysters there. And then, as John mentioned earlier, we have a partnership with the Cultured Abalone Farm to raise red abalone. And this partnership developed out of our partnerships with a variety of other academic institutions, as well as NOAA and the California Department of Fish and Wildlife, to save the endangered white abalone. The endangered white abalone was the first federally listed marine invertebrate. And we have developed at UC Davis and Bodega Marine Lab the techniques to reliably spawn them, fertilize them, grow them up. And now we have over 10,000 juvenile abalones that we're ready to outplant. And it's that collaboration with researchers doing that part of the life cycle of white abalone that has led to a lot of innovations in sustainability in our red abalone operation. And then finally, I hope that you're all hungry. You're hungry to hear about food security and sustainability from our oceans, and to hear from our next speaker, Carol Ann Clayson from Woods Hole Oceanographic Institution.